Hey Panthers! We are moving on to section 5.8, where we are not just deciding if figures are similar, but I'm going to tell you today that these figures are similar, and you're going to try to find some missing information. So we're looking at using similar figures today, and what we're going to focus our attention on is called indirect measurement. Indirect measurement. Indirect measurement is a method of using proportions to find the missing length in similar figures. So it's a method of using proportions, so we're going to be writing proportions today, and you use those proportions to find missing lengths. Basically what we're going to be doing is think back to last week when I gave you a problem like this. Let's do this. Okay. I gave you a proportion where I said 2 to 3 is equal to some number compared to 6. And if you recall, in order to solve for this missing x, we did cross multiplication. We said 3 times x is 3x, and we knew the cross products would be equal to each other, and so 6 times 2 is 12. And to get x alone, we divide both sides by 3, and we find out that x is equal to 4. This is what you're doing today, okay? But you're going to have to use the information from the shapes to set up your own proportion. They're not going to be given to you, okay? And we're going to continue using our colors. So if you can make sure that right now you have at least 2 colors in front of you, your calculator and your pencil, and if not, go ahead and pause me and return with 2 colors, calculator, and a pencil. Let's take a look at example 1. The directions say to find the unknown length in the similar figures. So again, it's telling us that these 2 shapes, which again are rectangles, because not all 4 sides are equal to each other, these 2 shapes are indeed similar. So what we need to do is start by finding the corresponding sides. Grab a color. Okay. Looking at our smaller rectangle first, I'm just going to kind of highlight the longer side of my rectangle. And this is 14. And then I'm going to take a different color, and I'm going to do the shorter side of my rectangle. And I find out that this is 12. Okay. Now I'm going to go to my larger rectangle. Again, I'm going to highlight the longer side, and again, you're going to have to eye this one because it's not labeled for you. But looking at this, is 48 the longer side, or is W? Hopefully you're thinking W. So again, I'm going to use my red for the longer side. The longer side is W. I'm going to grab my green to highlight the shorter side, in this case, which is 48. So looking over here, I was consistent, and I put the longer lengths on top and the shorter lengths on the bottom. Okay, and I have come up with 2 ratios here. Now again, remember, these shapes, these 2 rectangles are similar. Therefore, what do you know about the sides? The sides are proportional. Okay, and I know that I can solve for W here by doing cross multiplication. So let's go ahead and cross multiply. 12 times W is 12W, and this is equal to 48 times 14, which is, grab your calculators, 672. Now again, what we're doing today is we're solving for our variables. Right now, W is being multiplied by 12, so we do the opposite or inverse and divide both sides by 12. Grab your calculators. 672 divided by 12 is 56. And what are my units? What are we measuring our large rectangle with? Centimeters. So the answer, therefore, is 56 centimeters. So again, we're taking what we learned last week with proportions. We know that when we cross multiply, our products are equal to each other. And knowing that, all we have to do today is set up the proportions, giving the information that is in your problem. Let's take a look at example 2. It states the inside triangle is similar. So we know that the angles are equal and the sides are proportional. So the inside triangle is similar to the shape on the outside triangle. Find the length of the base of the inside triangle. Okay. So I'm going to grab my red. I'm going to highlight. I'm going to start with the longest side that I'm given. Again, I'm going to write it out just so I know I'm being consistent. I'm going to compare the long side to the short side. The long side in the big triangle is 12. And the short side of the large triangle is, well, it's not really the short side, but the other length that we're given. The nice thing about this is when you're doing these problems, you only need 2 sides. Even though this is a rectangle and there are 3 sides, we already know that they're similar, so you only have to choose 2. So 8 here, and then so we did the long side of the big triangle and the short side of the big triangle. Now let's do the long side of the smaller triangle. Do we know what that is? I'm going to use X. And the shorts, or the other side that we know of the triangle is what? 2. So again, these are the long lengths. These are the short lengths. Now we can solve this by cross multiplying. 8 times x is 8x, and we know this is equal to 2 times 12, which is x is being multiplied by 8, so you divide both sides by 8, and x equals 3 what? 3 inches. Make sure you label your units. Moving on. Example 3. Here we have a similarity statement. It says, triangle UVW is similar to triangle XYZ. Find the length of ZY. Okay? Let's start off with this. Remember in your similarity statements, if U comes first here, what comes first in this triangle? X. That tells us that U corresponds to X. I'm going to use my colors to circle these two. U comes first and X comes first in my similarity statement, therefore they correspond with each other. V is second and Y is second, so V corresponds to Y. And the last one, W corresponds to Z. Now that we have our colors, now we can set up our proportion using corresponding sides. Okay. I'm going to start with the long sides of my triangles. Okay, I'm going to start with the one on the left, the bigger one. Which of these is the longest side? So you're thinking 30. And again, keeping in mind 30 is between the red and the blue. Therefore, on my smaller triangle, which number is between the red and the blue? 12. Therefore, 30 and 12 must both be the longest sides of my two triangles. So again, I kept the longer sides on top. And now let's pick the next one. Again, let's take a look at x, because again, we want to make sure that we are including x. X here is between blue and green. Which number over here is between blue and green? 20. Okay, so when I set these up, remember this was my big triangle and this was my smaller triangle, so make sure you are consistent. For my big triangle, the side that corresponds to x was 20, and on the smaller triangle we had x. So here we have a proportion. Again, we are going to cross multiply. 30 times x is 30x, and 20 times 12 is 240. X is being multiplied by 30, so we're going to divide both sides by 30. And we find that x equals 8. Are there any units for this one? No units, so you have your answer of 8. Continuing on. Now, just to give you a heads up, this is how they caught Osama bin Laden. And I'm going to leave it at that and tell you a little bit more about that tomorrow in class. But example 4 is comparing the height to a shadow. And we'll talk more about that, how this technique of indirect measurement was used to catch the Osama bin Laden. So example 4 states that a 20-foot alien, so if you take a look at the alien, his height is 20 feet, in a movie casts a shadow that is 15 feet long. At the same time, and that's important, why would it matter at the same time if we're talking about shadows? What happens with shadows as the time changes? They move based on the position of the sun. Okay, so at the same time, a skyscraper casts a shadow of 240 feet. Do we know the height of the skyscraper? Nope, that's what we're going to try to find out. So you can use this technique to write a proportion, because with these two objects, the sun is in the exact same position, therefore the rays of the sun are coming down, and therefore the shadow is going to be proportional for both items. So let's start with what we know. Let's do height. Okay, the height of the alien is 20, and do we know the height of the skyscraper? No, so we'll use h. And then let's use the shadow. Again, this is the alien and this is the skyscraper. The alien shadow is 15 compared to the skyscraper shadow, which is 240. Okay, again, I have heights going across, shadows going across. I have the alien's measurements in one ratio and the skyscraper's measurements in one ratio. You have to be very particular about how you set up your proportions. So I'm going to cross multiply. 15 times h is 15h, which is equal to 20 times 240, which is 4,800. Grab your calculators, divide both sides by 15, and we get h equals 320. Again, h is representing the skyscraper. Look at the units for the skyscraper. What are they? Feet. Therefore, this answer will also be feet. Okay, Panthers, we are running out of time. What I would like you to do is take a look at example 5 on your own and just try it. Just try it. It says to estimate the height. I want you to use the real numbers and then just round your final answer, and then make sure you do the try it problems. Have a good night.